Today, we're taking a look at the deadly tornado outbreak that struck the South. The storms fired up Friday night, and over the next 2 days, those storms dropped 16 confirmed tornadoes, killing 24 people. The strongest tornado was an EF4 in Rolling Fork, Mississippi. It's the strongest tornado in nearly 3 years. And in Georgia, for the third time this year, a tornado has impacted the town of LaGrange. That's one tornado for each month of the year so far.
So that's a shocking statistic, and that begs the question, are we seeing more tornadoes in these large, long-track tornadoes? Is there a connection to climate change at all? Can we even answer that? We have Victor Gensini, is an associate professor at Northern Illinois University, joining us now to weigh in on the climate change conversation. Victor, thank you so much for being with us, and we'll get to more ins and outs of all this. But I want to start with that fact of that stat in Georgia, where we had a tornado, at least one tornado in this specific city within the last 3 months consecutively. Is that a sign? Can we link that at all to climate change?
Hey, Jordan. Hey, Felicia. Great to be with you. We can't link that individual event or even a series of maybe individual events 3 in a row to anything but bad luck at this point. However, if you start to aggregate over very long space and time scales and look at the trends across Georgia and Mississippi, say over a 50, 60, 70-year time period when we have good records for tornadoes, you start to see some pretty interesting values of shifts. In other words, increases in a place like Atlanta or Tupelo or Memphis in terms of the number of significant tornadoes through time, and actually a decrease in some areas of the Great Plains like Dallas-Fort Worth or Oklahoma City, where their trends, they still get a lot of tornadoes every year, but the trends through time have been downward.
So let's talk about those trends, because obviously a lot of eyes on the tornado that went through Rolling Fork, Mississippi, and you were recently part of a study that looked at those intense supercell storms like that. Are we seeing more of these stronger tornadoes because of our changing climate?
We certainly are in places of the Mid-South, and that study that you just referenced basically was trying to look at a very specific type of thunderstorm called the supercell, right? And you guys are familiar with supercells. These are the storms that have the rotating updrafts, very likely to produce large hail and tornadoes. And we simulated them in a regional climate model, and we did that because these perils, these tornadoes and hailstorms, like supercells, are very small scale, and our climate models can't resolve them. And so we rely on these regional climate simulations to do that. And essentially what happens is when you turn up CO2 inside of those models, these greenhouse gases that absorb and then re-emit that radiation back to the surface, you see an increase in the number of those supercells in a place like Atlanta or Memphis or Tupelo in the Mid-South. But also increase in their intensity. And we think that's due to the more vigorous updraft that future climate may support.
So if you look at, some of the data and we say since records began or in modern history, when you look back at, surface observations, we go back to some areas having recorded weather information from the 1800s. But how much time do we need for, let's say, tornado data to come in to when we feel comfortable saying, okay, this is linked to climate change? Or is it or not? Right.
Yeah, that's a really great question. It really comes down to time series analysis. And, generally for things like climate normals, when we say what is the average temperature, for example, for Atlanta, you probably want 30 years of data to make a robust assessment of what that distribution looks like. Every year beyond that, you kind of tack on more confidence as to what that range should look like. When you start looking at values through time, we are a relatively short temporal record in terms of tornadoes, starting in about 1950 or so. And if you look at the time series of overall number of significant tornadoes across the United States, that is pretty flat. But what's not flat is where they are. So you could have a national time series of tornadoes that's pretty constant, but it could be going up in a place like Atlanta and going down in a place like Oklahoma City, for example, and the overall average would be relatively constant.
Interesting. Yeah, okay, so it could change specifically maybe from neighborhood to neighborhood as in different cities, but not necessarily the overall number. Gotcha.
That does make a lot of sense. So when we're talking about kind of the overall number, of course, any tornado can do damage, but when you're talking about these really strong, long track tornadoes, and it feels like we're seeing more outbreaks, including multiple tornadoes, is there any way that we're going to be able to attribute that to the warming?
Yeah, another great question. Well, I'll tell you what, it's going to be hard to attribute an individual tornado specifically to climate change, but I like to look at this as sort of a probability issue. We have two die, and one die is climate change, and we're altering maybe a 5 to a 6 on that one die. The other die is human exposure and vulnerability, where we're changing a 5 to a 6 by increasing the size of our cities and increasing our exposure and footprint and vulnerability. And so any individual toss of the dice, we don't really know if that 12 that we get, for example, is a result of one or the other. But over a long sample size, we're pretty confident, right, that the number of these events are going to, and these tornado disasters are going to be increasing. Look no further than later this week. I mean, we're expecting another severe weather outbreak on Friday, potentially even Saturday coming up if you've looked at the forecast models. And I expect to see more tornado disasters this coming week.
And I mean, I would argue too, it's important that we keep the data science driven, because do you take this into your assessment, the awareness we all have when it comes to these big events? I mean, we've got social media, everything, everybody knows everything right away. So it's like, oh my gosh, everything's happening right now.
Oh, right. Hey, I mean, a tornado in 1950 in Kansas was not going to get reported right unless it hit a farmstead. Nowadays, we have storm chasers, right? That video's up on YouTube within 30 seconds. So there's clearly a reporting issue that we have to be aware of in the data set. But when we take these alternative data sources that have nothing to do with humans actually capturing data, things like satellite, things like temperature records, things like reanalyses data sets, they also support this kind of spatial change that we saw in that research study that you mentioned, and also just the trends in tornadoes in general across the U.S.
Totally. Well, we appreciate the work you're doing. We appreciate you being here with us. Victor Gensini with the Northern Illinois University. Thank you, thank you, thank you.
Yeah.
That's interesting, because
it
at
is
first
really
glance, anecdotal, everyone's saying, oh my gosh, this is because, but the reality is you got to look back at the data, which is so smart to do.
It's, again, as we point out quite often, the difference between weather and climate.
Sure.